Okay, so this is the the cutting the grass outside. This is the solutions to this test that we just did on Friday, and just stop me if you're unsure about what's going on. So the first question was just differentiate. When I differentiate, I'm going to write the same thing over here. So when I differentiate 7x squared plus 4x minus 3, when I differentiate that, it becomes, the 2 comes down in front, so it's 14x, the power reduces by 1, plus 4. Okay, and I gave 10 marks for that. Hopefully everybody got that. The next one caused a little bit of trouble. Again, differentiating, I've got 2x cubed plus 7x squared minus x minus 1. Now, I deducted 2 marks from you if you didn't write dy dx, and I stopped doing it after the first page. So, great. So here I'm differentiating this. So 2x cubed becomes, dy dx becomes 6x squared. 7x squared becomes 14x, and minus x becomes minus 1. So lots of you left off the minus 1. So you lost marks for that. So the 1 does become 0, but the minus x becomes minus 1. So dy dx is 6x squared plus 14x minus 1. And then this last bit, s of t. So it's, again, I just threw it in there because although it's written differently, it's still just differentiate. ds dt will be 6, because 6t becomes 6, minus 4t squared becomes minus 8t. And the 2 goes because it's a constant.
And do you have to write ds dt, or can you write dy dx?
Well, yeah, I think I gave it to you if you wrote dy dx, because you showed that you differentiated. Yeah. Now, whether in an exam they might, I think they're trying to find you marks, so, okay. Any questions on that one? Good. Okay, over the page then. So if y is equal to 5x squared plus 4x minus 2, find the value of dy dx when x equals 3. So you can see here, dy dx is going to be 10x plus 4. So I found dy dx. X equals 3 means I sub 3 into dy dx. So dy dx is going to be 10 by 3 plus 4. So 30 plus 4, which is 34. Okay, and there was 15 marks for that, 5 for differentiating, 10 if you subbed in the 3, and then 15 if you then found the value of that correctly. Okay? If y equals x cubed minus x squared minus 3x plus 7, find the slope of the tangent to the curve at the point where x equals 2. These two questions are actually the same. The same action is needed. In both cases, you're going to differentiate and sub in an x, but notice here we've got find the slope of the tangent to the curve, so it's much harder to make that jump. What are they asking me to do? What are they talking about, the slope of the tangent to the curve? But it's just saying find the value of dy dx at where x equals 2. So again, I'm differentiating. So slope, and again, get into the habit, if slope comes up, write down slope equals dy dx. I think a couple of you did that every time, which was really good. It's going to get you marks. If you don't do anything else except write down slope equals dy dx, it'll get you marks. So dy dx is equal to 3x squared minus 2x minus 3. And the 7 goes. And then x equals 2. So at x equals 2, dy dx is equal to 3 by 2 squared minus 2 by 2 minus 3. Now, 3 squared is 3 by 2 squared means I square the 2 first. So it's 3 by 4 is 12 minus 4 minus 3, which is 5 altogether. That's really important. So a few of you making that slip, you square the 2 first, get 4, and then multiply the answer by 3. And again, I gave 5 marks for differentiating correctly, another 5 marks for subbing in correctly, and then up to 14 if you got dy dx is equal to 5, but then I wanted you to make the connection that the slope is 5. So I intended to only give you 15 marks if you wrote down slope equals 5. If I gave you the marks without doing that, well then just be thankful. Okay? So the slope is 5. Any questions on that one? Okay. Question 3. I think I'm going to need more paper for this one. I'll do it down below here. So in question 3, find the slope of the tangent to the curve y equals x squared minus 4x plus 5 at the point 3, 2. Hence, find the equation of the tangent to the curve at 3, 2. And I gave you the formula for the equation of a line. So find the slope of the tangent. So again, slope equals dy dx. So I would be writing down, if I do this question, I'll just cover up my solution and write it here. Okay, so the slope equals dy dx. I'm writing that down first of all. And when y equals x squared minus 4x plus 5, then dy dx is equal to 2x minus 4. So I've got some marks already by differentiating. Find the slope of the tangent to the curve y equals x squared minus 4x plus 5 at the point 3, 2. The only bit that matters here is the x value. To find the slope, I just need to know what x is. X is equal to 3. So the slope is equal to dy dx, which is 2x minus 4. At x equals 3, that's 2 by 3 minus 4, which is 6 minus 4, which is 2. So the slope is 2. Now, some of you did really well on this in that you didn't know what to do, but you still subbed into the equation of a line formula. So well done. And that's really good. I like that exam technique. So you're not really quite sure what's happening, but you know you can sub in 3, 2 into that. So 3, 2 is x1, y1. The slope is 2, so the slope is m is 2. And then we've got y minus 2 is equal to 2 by x minus 3. So y minus y1, there's y1, which is 2. X minus x1 is x minus 3. And I'm multiplying it by the slope, which is 2. So y minus 2 is equal to 2x minus 6. So then I'm going to add 2 to both sides. Y is equal to 2x minus 4. So the equation of the tangent to the curve at 3, 2 is the equation of the tangent to the curve is y is equal to 2x minus 4. Okay, anybody want to ask me about that? That's a difficult question. Like, that's multi-step. I had broken it down for you, and I think they do break it down for you now, but that's a difficult thing to do. Did anybody want to ask me about anything on it? And that was, what did I give? 20 marks for that.
And for that, would you not leave the minus 3 going after that?
No, because it's not what we're solving here. Firstly, we're not solving, we're subbing in an x equals 3. And secondly, what we would be solving doesn't have an x squared. It just has, it's a linear, it's just an x to the power of 1. Okay? Any other questions? Okay, so over the page then. At what point on the curve y equals 2x squared minus x minus 4 is the slope of the tangent equal to 3? So again, writing down slope equals dy dx. And again, I'll do this, the whole question under here so that I can rewrite it. So I've got the curve is y is equal to 2x squared minus x minus 4. I see slope, so I'm writing down dy dx is equal to the slope. Okay, and it's equal to 3. So I might even at this stage want to write down dy dx is equal to 3. So as soon as I see slope equal to 3, I'm making that connection, dy dx is equal to 3. Okay, so I've got to differentiate first. Dy dx is equal to 4x minus 1, 2 by 2x and reduce the power by 1, and minus x differentiates to minus 1. That minus 4 is a constant, so it's gone. So now I know 4x minus 1 is 3. So 4x, if I add 1 to both sides, 4x is equal to 4, so x is equal to 1. So I know that at what point, I know that at x equals 1, the slope of the tangent equals 3. So at x equals 1, slope equals 3, but I'm asked for the point, and a point is always an x and a y. I have my x value, so my y value is 2 by 1 squared minus 1, because x is 1, minus 1, minus 4. So what did I do? I went back to y is equal to 2x squared minus x minus 4 from the question. And I subbed in 1 for x. So I've got 2 by 1, minus 1 minus 4, so 2 minus 5, so minus 3. So I found out that y is minus 3, x is 1, so at the point 1 minus 3, the slope of the tangent equals 3. Again, that's a difficult question, that's multi-step. And it's all the time just getting used to what they mean when they say slope of the tangent, and what they mean by when they say that it equals a certain number rather than at a certain point. It's just getting used to that. Any questions? Okay, and then the next one said, I gave 15 for that. Find the values of x for which the function 2x squared plus 8x minus 5 is increasing. So let's break this down a bit. So the values of x for which the function y is equal to 2x squared plus 8x minus 5 is increasing. So this was the bit probably that caught a lot of you, was increasing. Now, lots of you found dy dx and put it equal to 0, and you got some marks, because that's great. You knew you had to differentiate, and then you put it equal to 0 because you remembered something about that. It's well worth doing. If you're not sure what you're doing, it's well worth doing that. Increasing means the slope is positive. Remember, it's like that. If the slope is positive, then dy dx is positive. And what do we mean by dy dx being positive? We mean dy dx is greater than 0. And this is what's called an inequality. So if it's not equal to 0 but it's greater than 0, or if it's not equal to 0 but it's less than 0, then we're going to solve what's called an inequality. So that's an increasing slope, positive slope, dy dx is greater than 0. So let's dy dx at first anyway. So dy dx is equal to 4x plus 8. And this is going to be greater than 0. So 4x plus 8 is greater than 0 is what I've been asked to solve. Now if you remember, I think we've touched on inequalities, but I guess we'll probably revise them again just in case. Maybe we'll do that tomorrow. What we're doing here, 4x plus 8 is greater than 0. I treat it like an equation. So I'm going to subtract 8 from both sides. 4x is greater than minus 8. And then I want to find 1x like I do with any equation. I find 1x, so divide by 4, and I get x is greater than minus 2. So what I found is that for any of the x values that are greater than minus 2, the function will be increasing. The slope is positive. So I presume that's what's happening, is that because it's a plus x squared, so here's a plus x squared curve, I'm presuming it's increasing here. So what I've just found out is that the x coordinate here must be minus 2. Okay, so it's decreasing until it gets to minus 2. There must be a minimum at minus 2, and then it's increasing for the rest. X is greater than minus 2. So the function is increasing. Function is increasing when x is greater than minus 2. So lots of you fell down on that. I'm not sure whether anybody got that right, actually, because of this idea of the greater than 0. So when x is greater than minus 2. Does anybody want to ask me about that? So if it was decreasing, let's just do that over here, an aside. So if it was decreasing, then it would be that dy dx is less than 0. So you'd be solving some kind of inequality where it's less than 0, and your answer would be x is less than whatever the number is, 3 or 5 or minus 2 or whatever. Okay? Okay, find the coordinates of the local maximum of the curve. So let's do this one. So I was hoping that you'd all get this, because we'd done a few of these, but hopefully soon you'll all get it anyway. So find the coordinates of the local maximum of the curve. So y is equal to 5 plus 6x minus x squared. Now, maximum, I'd be writing down dy dx is equal to 0, because the slope is 0. I'd write all of that down. Okay, get into the habit of writing that down, because you never know, you might freeze, but if you're getting into the habit of writing dy dx equal to 0, you might remember something. Okay, so dy dx is equal to, well, the 5 is gone, so it's 6 minus 2x. At a maximum, dy dx is equal to 0, so dy dx is equal to 0 means that 6 minus 2x is equal to 0. I'm going to subtract 6 from both sides, so minus 2x is equal to minus 6, and then divide by negative 2, x is equal to 3. So find the coordinates of the local maximum. So coordinates, so this is just x equals 3. The coordinates means an x and a y, so I have to find the y. I know that x equals 3, but I've got to go back to my original function 5 plus 6x minus x squared. When x equals 3, y is equal to 5 plus 6 times 3 minus 3 squared, so 5 plus 18 minus 9, so 23 minus 9, which is 4. So what I found out is that when x equals 3, y equals 4, and we remember that x equals 3 is where the maximum happens at. It happens at x equals 3. So the coordinates of the local maximum are x equals 3, y equals 4. So x equals 3, y equals 4, or 3, 4. And I gave 15 for that. And this is just how I laid it out again. I wrote down at x equals 3, it's a maximum, and then I worked through. Okay, and that's how the marks broke down. 5 for differentiating, 7 for saying it had to equal 0, 10 for solving for x, and then 15 for getting your y value as well. Okay. And then the last one, which is quite nasty, which I just threw in for those of you that I knew would want to try one of the harder ones. So, find the coordinates of the two turning points of the function. So, by this stage, I'm hoping that many of you realize that turning points mean max and min, and that again, at a max and at a min, dy dx is equal to 0, and that's because dy dx is the slope, and a slope of 0 happens when we've got a min there and it's a line straight across, and we've got a max there, it's a line straight across. And as I was saying to my second years today, when there's not going up or down, it's got a slope of 0. And the tangents to the curve at those 2 points aren't going up or down, they've got a slope of 0. So, turning points are maxes and mins, dy dx equals 0, so I'm going to find dy dx first of all. So y is equal to x cubed minus 3x squared minus 9x plus 6. So dy dx is equal to 3x squared minus 6x minus 9. And this is where we're going to use our minus b formula. Okay, because it's an x squared and because it equals 0. Okay, so dy dx is equal to 0 because it's a max and a min. So 3x squared minus 6x minus 9 equals 0. So you can either use your minus b formula. So let's do that first, because I think that's what most people will have done. A is equal to 3 B is equal to minus 6, and C is equal to minus 9. So then it's minus B plus or minus the square root of B squared minus 4AC all over 2A. So minus B, so minus 6 plus or minus the square root of minus 6 squared minus 4 by 3 by minus 9 all over 2 by 3. So minus 6 is plus 6, plus or minus the square root of minus 6 squared is 36, minus 4 by 3 by minus 9 is plus 108. But you'll have done all this on your calculator anyway. And 6 plus or minus root 144 over 6, so 6 plus or minus 12 over 6. So we get 18 over 6, which is 3, and we get minus 6 over 6, which is minus 1. So at x equals 3 and x equals minus 1. So all I've done there is solve the quadratic equation. Now some of you may have solved it by factorizing. If I was doing that, I'd have divided across by 3. And I'd have got x minus 3, x plus 1. So x equals 3, x equals minus 1. Okay, so I now know the x coordinates of the max and the min, but to know which is which, I'm going to have to find the y coordinates. So find the y, x cubed minus 3x squared minus 9x plus 6. So at x equals 3, y is equal to 3 cubed minus 3 by 3 squared minus 9 by 3 plus 6. So 27 minus 3 by 9 minus 27 plus 6. So there's lots of 27s here. So we get minus 21 when we do all that. So at 3 minus 21, there's a max or a min. And then at x equals minus 1, y is equal to minus 1 cubed minus 3 by minus 1 squared minus 9 by minus 1 plus 6. So minus 1. Again, you can stick all this in your calculator. So that's 11, I think, isn't it? So y is equal to 11. So at minus 1, 11, and at 3 minus 21, one of those is a max and one of those is a min. So if we look at the y values, so look at y values and imagine them on our graph. Minus 21 is going to be way down here, and plus 11 is going to be up here. So this must be the max, and this must be the min, because this is higher up than this one. So this must be the maximum, and this must be the minimum. So the minimum is at 3 minus 21, and the maximum is at minus 1, 11. Now again, that's a multi-step problem, so it's really tough. Like this is very different to what you're used to from junior cert. Now I know you're well out of junior cert, but it's still very tough. So we had a few steps there. We had the first step where we differentiated, we put it equal to 0, and we had an equation, a quadratic equation. We then could either use the minus b formula, or we could factorize and solve. Either way, we ended up with x equals 3 or x equals minus 1. We then had to find the y values that went with that, because we were being asked for the coordinates of the two turning points, and anyway we needed to know the y values so that we know which is the max and which is the min. So we subbed it into the original function and got our two values, and we found out that 3 was with minus 21, which is much lower down than minus 111. So this must be the minimum and this must be the maximum.